So we're going to start particle motion. Don't get hung up on the word particle. Don't think of that as like a speck, like a dust speck or something super tiny. It just means anything that has motion. So your particle could be a car or a train or a hot air balloon or a person, just anything that's moving. It just means something that's moving. Okay, so don't get hung up on that word particle. All right, we're going to go through a lot of these definitions here, and if you've taken physics, some of this is going to be familiar, which is cool. There's a good bit of overlap between calculus and physics, so if you've already taken that, then you'll be like, oh, this is familiar, and then that always feels good, like, oh, I already know this. And if you haven't taken physics, that's going to be fine too. Some people are like, oh, I wish I had known this before I took physics, and that I cannot change or help you with. But if you don't print these notes, if you don't have a printer, at the very least, you need to write down these definitions with me so that you have them. All right, so position is typically written S of t, and that is just where the particle is. And so that unit would be something like feet, or it could be meters or miles or kilometers or whatever have you, but it's just going to be a distance measurement. It's just where the particle is. And again, the particle is just something that has motion. Velocity is written v of t, and it is the derivative of position. So first derivative. Sorry, I know that glare is bad. I'm trying to fix a little bit. All right, so S prime, so the derivative of position. And so this is the rate of change of the particle. And so those units would be something like feet per second. I'm just writing that as an example. It could be miles per hour or kilometers per minute, something per something else. So you're gonna have a distance and a time measurement. Right, now, velocity is directional. So if your velocity is positive, greater than 0, that means your particle is moving in a positive direction. And that can mean different things based on the context of the problem. Like it could be moving upwards or to the right or further away from something. Just it depends on what the story problem is about. And if your velocity is negative, you're moving in the negative direction, which could mean to the left or downwards or closer to an object or something. And if your velocity is 0, that means your particle is at rest, which means that it is not moving, so stationary. Acceleration is a of t, and that is the derivative of velocity, which means it is the second derivative of position. And so that is a rate of change of your particle. And so units for that would be, for example, feet per second, or feet per second squared. But again, it could be miles per hour squared. It could be whatever units are given in the problem, but it's going to be something per something else squared. So if your acceleration is positive, that means that your particle is being pulled in the positive direction. It might not be moving in the positive direction, but it's being pulled in the positive direction. So being pulled forwards or pulled upwards. And if your acceleration is negative, you're being pulled in the negative direction. And if your acceleration is 0, that means you have a constant velocity. It doesn't mean that you're not moving. You are moving. It's like cruise control. You've set cruise control on your car, so you are moving at a constant velocity. Your velocity isn't changing, in other words, if you have a 0 acceleration. But this positive and negative does get people. The example I always use is pretend you're driving in your car and you're driving forwards. So if you're driving forwards, you have positive velocity. Your velocity is positive. You are moving in the forwards direction. But say you see a red light and you hit the brakes. Does your car immediately start going backwards when you hit those brakes? No, I mean, that would be awful. That would be some serious whiplash. When you hit the brakes, you're still moving forwards. You still have positive velocity. When you hit the brakes, that makes you have negative acceleration. Okay, you're being pulled back, right? Which leads me to the next thing we're going to talk about, which is speed. That is the absolute value of velocity. So velocity is directional, but speed is not. If you put your car in reverse and move, your speedometer is still going to go positive. You're moving positive miles per hour, just backwards, right? So in order to be speeding up, so speed increasing, that means that your velocity and acceleration are the same sign. So they could both be positive, but they could both be negative. An example of them both being positive is like you're in your car and you're moving forwards. So you have a positive velocity because you're moving forwards, and you're pressing down on the gas pedal. That gives you a positive acceleration. So you're going to be speeding up. Now they can both be the same sign and be negative. This would be like if you were skydiving and you jumped out of an airplane, you're moving downwards, so you have negative velocity, so you're moving towards the ground, and gravity is pulling you down, so you also have negative acceleration, so you're speeding up in the negative direction. So that's them being the same sign, and slowing down is when velocity and acceleration are opposite signs. And this is like the example I just brought up. If you're driving in your car and you see a red light, when you hit the brakes, you still are moving forwards. You have positive velocity, but you have negative acceleration. And that's why you slow down when you hit the brakes in your car. Those are opposite signs. The most common mistake is when you get asked about speeding up and slowing down, which they will ask you this on the AP exam. This shows up every year. When they ask speeding up and slowing down, people will just look at acceleration and they'll forget to look at velocity. You need them both in order to talk about speeding up, slowing down. So same sign, opposite signs. So let's try some problems. So number one, a particle is moving, and remember, a particle is anything with motion. All right, a particle is moving along the line with its position given by this equation for positive times. We've got seconds and feet. If there are units in a problem, you need to make sure you put units in your answer. Don't forget about that. You'll lose a lot of points real quickly if you forget to put units on everything. So letter A says find the velocity and acceleration functions. All right, velocity is going to be the derivative of this. So that would be 3t squared minus 3. And then acceleration is going to be the next derivative. So derivative of velocity would be 6t. So B says, when is the particle at rest? That means it's not moving. So that means the velocity equals 0. So velocity equals 0. We're going to set this equation equal to 0 and solve it. So we're going to add 3 and then divide by 3. And then we would square root. Now, typically you would get plus and minus 1, but we're not going to do negative times. So we're just going to take the positive one and then just make sure you put units with it. So at time 1 second, our particle is not moving. It is stationary. And then we're going to fill in this chart for position, velocity, and acceleration. So we're going to just plug these numbers 0, 1, and 2 into the functions. So let's do position first. Here's position. If I plug in 0, I'm going to get 2. That means that that's where the particle is, at 2 feet. All right, if we plug in 1, that's going to be 1 minus 3 would be negative 2, plus 2 would be 0. So that's, again, where the particle is. So if you want to consider 0 like home, that's where the particle is at that time. And then plugging in 2. 2 cubed would be 8, minus 6 would be 2, plus 2 would be 4. So it starts at 2, goes to 0, and then back to 4. And we're going to draw a number line in a second so that you can see this motion happening. All right, and then we're going to plug those numbers into velocity, which is right here. So if we plug in 0, we get negative 3. So that means the particle's moving in the negative direction. You have negative velocity, in this case, moving to the left. If we plug in 1 to velocity, that's going to give us 0. And that makes sense. At 1 second, that is when our particle stopped. It was not moving. And then if we plug in 2, 2 squared is 4, times 3 is 12, minus 3 is 9. So that's a positive velocity, so the particle would be moving to the right, moving in the positive direction. And then acceleration, if we plug in 0, we get 0. That's like cruise control, constant velocity. And then if we plug in 1, we're going to get 6. And if we plug in 2, we're going to get 12. So it starts out like on cruise control, and then we have a positive acceleration, meaning it's being pulled to the right. So draw a number line indicating the position of the particle, right? This is just to give you a visual. I'm a real visual learner, so I like to actually see what's happening here. Our particle starts at 2. Just going to put 2 right here. And I'm just going to draw a circle. You can draw whatever you want. You can draw a star. It doesn't matter. This is just my object that's moving. And then it goes to 0. So here's 0. So it goes from 2 down to 0, and then up to 4. So we start here, we move to the left, and then we move back to the right. So write a description. We're just going to write this out in words. Just, you know, if you're not a visual person, if you're a words person, we're going to write out what happens in words. So our particle starts at 2 feet. So that's where we begin. And then it moves to 0 feet. And as it's moving there, it is slowing down. And the way I know it is slowing down is when I look at the velocities in between 0 and 1, those would be negative values. In between -3 and 0, those would be negative. And if I look at acceleration values in between 0 and 6, those would be positive. So one's negative, one's positive. That means slowing down. All right, and then at 0 feet, the particle stops. We have a 0 velocity there. So particle stops at 0 feet. It is motionless. It is at rest. And then it moves to 4 feet and is speeding up. And the way I know it's speeding up is I'm going to look at velocity and acceleration. In between 0 and 9, those would be positive values. And in between 6 and 12, those would also be positive values. So we're speeding up. They are the same sign. And we're speeding up in the positive direction since they're both positive. And then F is, what is the total distance traveled by the particle? Well, we're just going to add up all the motion. So if we go from 2 to 0, that's 2 feet. Plus, if we go from 0 up to 4, that would be 4 feet, and so a total of 6 feet. So it really helps to have the number line so that you can add up all the left and right motion to get the total distance. And we'll do a couple more and then I'll give you guys a break. This is basically just practice, practice, practice at this point. The material that you need to know is all right here. We're just gonna practice doing a bunch of problems. Oh wait, question. You mean this right here? That was position. So we plugged 0, 1, and 2 into the position function, which was this one right here. So that was the one that was given in the problem. So when we plugged in 0 for time, we got 2. And then when we plugged in 1, so that would be 1 minus 3 would be -2, plus 2 would be 0. And then when we plugged in 2, that would be 8 minus 6, which would be 2, plus 2 is 4. So I plugged them into the position function. And then for the other rows, I just plugged into velocity and acceleration. All right, so for this one, instead of an equation, we're given this graph, and it is the graph of velocity. So be really aware of what they gave you. They gave us the velocity graph in this case. That's the first derivative. So this is the derivative graph. Showing from times 0 to 11. There aren't any units in this problem, like seconds or feet or meters or anything like that. So don't make them up. If there just aren't any, you just don't put any. And we have a semicircle and 2 line segments. Use the graph to answer the question. At what time is the speed of the particle greatest? Be really careful because this is a really subtle difference here. It's a graph of velocity, but they're asking for speed. So remember, speed is the absolute value of velocity. So if you want to pretend all of these values are positive, the place where the speed is greatest is going to be right here. I realize that velocity is -6, but if you absolute value that, you would get +6. So that's where we have the highest speed. Now they didn't ask for the speed, they asked for what time. So the time on the x-axis is 8. So time is 8. And again, we weren't given a time unit, so I'm not going to put any like hours or anything with that. Letter B, at which of these times, 2, 6, or 9, this is basically multiple choice, is the acceleration the greatest? Explain your answer. All right, well, what I would do is just find each of these accelerations. And then my explanation is like, that's the biggest one. There's not really anything else you have to explain if you've shown what all three of them are. So this is velocity. Acceleration is the derivative of velocity. And remember, derivative means slope. So that's going to be the slope at each of these points. We've done this before. We're just calling it acceleration now. Before it was called derivative. You know, an acceleration is a derivative of velocity. So we want the slopes at each of these values. So here's 2. If I draw in a tangent line, what slope does that have, guys? Let me throw these questions at you because I've been talking for a long time now. What slope do we have at 2? Good, so that one's 0, so it's probably not going to be the greatest. All right, and then at 6, so 6 is right here. So we want the slope of this line. So let me zoom in. Can you guys tell me the slope of that line at 6? We want the slope of this line. And I can draw in the triangles to help you guys. I know you're trying to look at it on a screen, and I get that that's really hard. Yeah, there we go. -3/2. So it goes down 3 over 2. Now I'm zoomed in so far here. All right, so -3/2. And then the last one was 9. So we want the slope at 9. So here is 9. And I'll, again, draw in the triangles here for you. What is the slope of that line at 9? Good. It's going up 3 over 1. So that slope would be 3. All right, so at which of these times is the acceleration the greatest? And that would be at time 9. And I know it said to explain your answer, but we don't really need to because we showed what all of them are. I mean, what would you write? Because that one's bigger than these two. You know, this is your explanation. At time 9 is when we have the biggest acceleration. All right, C, over what time intervals is the particle moving to the left? Explain your answer. Moving left would be when velocity is negative. This is your graph of velocity. So negative would be below sea level. We want where this graph is negative. That means moving in the negative direction. So that would be from here to here. And so that is from 4 to 10. So that would be from 4 to 10 because velocity is negative there. So from 4 to 10, because velocity is negative there. Moving to the left means we want negative velocity. All right, and then over what time intervals is the speed of the particle decreasing? All right, speeding up and slowing down. What they're asking for here is slowing down, speed decreasing. You have to look at both velocity and acceleration. So what I'm gonna do off to the side here, I always just make a number line. We're gonna go from 0 to 11. And I'm gonna put velocity on the top and acceleration on the bottom. Some people don't like to make a number line. This is gonna be up to you, like personal preference. I like to make a number line. And then any number where this graph turns around or touches 0, we're gonna need on our number line. So I'm gonna need 2 and 4. And this point right here is 8. And 10. And so I'm going to put velocity signs on the top, positive or negative, and then acceleration on the bottom, positive or negative. So this is the velocity graph. Positive would be above sea level, negative would be below. So velocity is going to be positive until 4, and then negative from 4 to 10, and then positive again from 10 to 11. Acceleration is the slope of velocity. So now we're looking at, is the graph increasing or decreasing? So for this first section, our graph is increasing. We would have positive slopes there. So acceleration would be positive 0 to 2. And then we're decreasing all the way until 8. So acceleration will be negative all the way until 8. And then our graph is increasing again. So acceleration will be positive from 8 to 11. And so this question was asking, where is the speed decreasing? That would be where velocity and acceleration are opposite signs. Remember, speeding up means they're the same, slowing down means they're opposite. So here they're opposite, and here they're opposite. So that's going to be our answer, from 2 to 4 and from 8 to 10. Because velocity and acceleration are opposite signs there. It is a little bit of writing when it says explain your answer or justify. You know, you have to write out why. But because velocity and acceleration are opposite signs. Again, some people can do that without making a chart. That's fine. This is not like a requirement. It just helps me to put the signs on there, so that's why I do. All right, we'll do one more and then we'll take a break. You do need a calculator for this one. So if you have your calculator handy, go ahead and get that out. If not, just follow along with me. But again, you're going to need one for the AP exam. So if you don't have one and you're planning on taking that exam, you're going to need to get it. Also, you're going to need to be able to take tests in this class, and you're going to need a calculator. So, all right. This says the rate of change in kilometers per hour. All right, so since they're giving us kilometers per hour, that means that this is a velocity. They gave us a velocity function. Of the altitude of a hot air balloon is given by, and then they called it R of t for rate, but this is a velocity function. From 0 to 4 hours, time is in hours. Assume the balloon is initially at ground level. So it starts on the ground. That should make sense because you can't get in the hot air balloon unless it's on the ground. So let's take a look at this equation and see what is going on with this. I'm going to go to y equals, I know it says t, but I'm going to type x. So we'll have x cubed minus 4x squared plus 6. And before you hit graph, make sure you fix the window. Our window is from 0 to 4. So window is right here, and I'm going to make my x's 0 to 4. I'm going to leave the y's negative 10 to 10 for right now. I may end up changing that. We'll just have to see what it looks like. But our balloon ride is from 0 to 4 hours. And so what always happens when I shine this up here is people say, oh, the balloon starts up in the air. No, it doesn't. It starts on the ground. This is not the position graph. This is velocity, all right? So for these times, velocity is positive. Look at above sea level, all right? So for this portion, from here to here, from 0 until whatever this is, about 1.5, velocity is positive. That means the balloon moves upwards, which makes sense. If it starts on the ground, the only place it can go is up. So it moves up. And then for this portion where velocity is negative, it's going to move down. And then for this portion where velocity is positive again, it moves up. So my question to you is, and you can just type yes or no in the chat, should you get out of the balloon at the 4-hour mark? Would it be a good idea to get out of the balloon at 4 hours? No is correct. Why would you not want to get out of the balloon? I mean, you may want to get out of the balloon at the end of 4 hours. That's a long ride. You may be like ready to be done with it, but why shouldn't you get out at the end of 4 hours? Yeah, it's still going up. We have positive velocity. The balloon is not on the ground. It's up in the air. So if you got out, you would fall. The balloon is up here in the air. So don't get out at the end of 4 hours, despite that you might want to, unless you have a parachute or something. All right, so that's what's going on. Letter A, for what values is the altitude decreasing? All right, well, that would be from here to here. And so we're going to just need the calculator to give us those values. So I'm going to go to calculate second choice. And I want a 0. And I'm trying to get this value right here. It looks to be about 1.5. Now it's going to ask you left bound, right bound, guess. So for my left bound, I'm going to make that 1 enter. For my right bound, I'm going to make that 2 enter. And for my guess, I'm going to put 1.5 enter. And you can do that by moving the cursor as well. I just find that annoying, so I just like to type it in. But here it is, and you need 3 decimal points. So 1.571. You can just take the first 3. So 1.571. So for what values is the altitude decreasing? 1.571 until this value. So I'm going to do the exact same thing. I'm going to calculate a 0. Now that one looks about 3.5. So my left bound is going to be 3. Right bound is going to be 4. Guess is 3.5. And it would be 3.514 hours. All right, so those are the values where the balloon is decreasing. If you need a reason, it would be because velocity is negative there. I know it didn't say that in this question, but just trying to be really thorough. And also, let me just put some hours with that. All right, so B says, find the value of r prime of 2 and explain what it means, use units of measure. All right, so first we're going to find r prime, and then we're going to plug in 2. So this derivative of r would be 3t squared minus 8t. And just to review what we've done so far, this is velocity. So what did I just find? If I did the derivative of that, they gave us a velocity function. So if I just did the derivative, what is this an equation of? Yeah, good. So that's going to be acceleration. Nice. All right, so let's plug in 2. 2 squared is 4, times 3 is 12, and then 2 times 8 is 16. So 12 minus 16 would be -4. And so we have a -4 acceleration, right? That means, this says, explain what it means in context of the problem. That means the rate, or you could say the velocity, is decreasing because we got a negative result. The rate is decreasing for, now what are the units? This was kilometers per hour. So for acceleration, it'll be kilometers per hour. So kilometers per hour squared at time 2 hours, because that's what we plugged in. So the rate is decreasing. If we had gotten a positive result, we would have said the rate is increasing. I didn't put a negative. You're probably like, why didn't she put a negative? Because I said decreasing, so that covers the fact that it was negative. If you said decreasing -4, that's like a double negative. So the rate is decreasing for kilometers per hour squared at time 2 hours. All right, letter C. When is the balloon closest to the ground? All right, here's our rate function. The balloon starts on the ground. It goes up for all of this, and then it goes down for all of this time. So the time when it's closest to the ground is going to be right here. It's finished moving downwards, and then it's going to start moving upwards again. So at this time, which was 3.514 hours. And then the last one, when is the balloon at its maximum altitude during that time? So when is it the highest up in the air? Well, again, here's our graph. It starts on the ground and then it moves up for all of this time. Right here at this time is when it starts moving back downwards. So this would be when it's at its peak. And we found that earlier. It was 1.5 something, whatever that time was. I don't need to calculate it again because I found it up here. 1.571 hours is when it was at the most high off of the ground.